Hello students, our topic of discussion today is cells. Now, what is cell? An electrical cell is a device which acts as a source of electricity, and it is something which converts chemical energy into electrical energy. That means there is some chemical energy stored inside the cell, okay? And when we start using the cell, this chemical energy gets transformed into electrical energy. Now, how do we get this chemical energy? Because we know from our previous knowledge that a cell consists mainly of three things here. The two terminals, one of which is anode and the other one will be acting as the cathode. And inside the cell we have electrolyte which undergoes electrolysis and it breaks down into positive and negative ions which get deposited on the terminals, and there is a potential difference created between the terminals which will be acting as a source of electricity. Now there are a few terms related to cells here. The first term is EMF of the cell. EMF, the full form is electromotive force of the cell. It is defined as the potential difference between the terminals of the cell when there is no current drawn from the cell. That is, when the cell is in open circuit, you don't connect anything to the external of the cell. The potential difference existing between the terminals is called EMF of the cell. Now the second term here is terminal voltage. Now looking at EMF, the definition was when there was nothing connected to the external circuit. Now to define terminal voltage, we will just connect a load or something which draws current from the cell. Say the value of resistance of the load is R. So when the cell is in closed circuit, that means when current is drawn from the cell, the potential difference existing between the terminals of the cell is called its terminal voltage, denoted by V. EMF usually is denoted by the letter E. Now, from the definition you have seen that both of these are the potential differences, and we can also define potential difference in terms of work done. Now, let us define EMF and terminal voltage in terms of work done. EMF is the amount of work done or energy spent in taking a unit positive charge around the complete circuit of the cell. That means you take a positive charge starting from here through this path, and then you also have to take the charge from inside the cell also. That means you take the charge through the entire portion of the circuit. That amount of work done will be equal to EMF of the cell. Now terminal voltage is also equal to the work done in carrying a unit positive charge around the circuit but connected across the terminals of the cell. That means EMF was like this. That means you're carrying the charge throughout the cell, but to define terminal voltage you just need to take the charge through the external circuit only. Now when you compare the work done in these two cases, EMF was the entire thing and terminal voltage is only from the external circuit. Naturally, terminal voltage will be lesser than EMF. Now, EMF, if you subtract the terminal voltage from the EMF, you are getting a slight drop in the voltage. That is called voltage drop. We denote voltage drop by small letter V. Now voltage drop can also be defined in terms of work done because it is also a potential difference. Now what amount of work done? You can see EMF, work done throughout the circuit, terminal voltage, work done through the external circuit. Now what amount of work is left? The work left is carrying the charge through the electrolyte of the cell. That means voltage drop can be defined as the work done in taking a unit positive charge across the electrolyte of the cell. Now you can see these three terms here: EMF throughout, terminal voltage through this, and voltage drop through this. Okay, now just we will try to find out an expression relating EMF and terminal voltage. It is nothing but EMF minus V is equal to small v. Now let's define all these in terms of work done. EMF is work done per unit charge. Taking infinitesimally small steps, we can write dW by dQ. Let us write terminal voltage as d small w by dq. Naturally, this is smaller than the previous one. And let us say small v, that is the voltage drop, is equal to dw dash by dq. Now, this total work done will be equal to the sum of these two work dones. So, let's write it in expression. dw by dq is equal to d small w by dq plus dw dash by dq. This is the work done in taking the charge throughout the cell, that is outside and inside the cell. This is work done in taking the charge outside the cell, and this is work done in taking the charge inside the cell. Now we may cancel these, so we will be left out with dw is equal to dw plus dw dash. Now you know potential is equal to work done per unit charge. So what is work done equal to? Is equal to V into dq. Now this V will be replaced as per the respective terms, that is EMF, terminal voltage and voltage drop. So in this case, this is related to the EMF, so we can write it as epsilon dq will be equal to d small w. This relates to the terminal voltage, so it is V dq plus, and this relates to the potential drop, so this will be equal to small v dq. Now you know charge can be written in terms of current, because current is equal to dq by dt. So dq will be equal to I dt. So we are replacing dq by I dt there, into I dt is equal to V is also I V is IR from Ohm's law, dq plus, this can be written as IR, but here since we are not dealing with the external circuit, we are dealing with the internal circuit only, and the resistance existing inside the cell, that is resistance because of the electrolyte, will be called the internal resistance, so it will be I into R. This voltage drop is because of the internal resistance of the cell, so this small r stands for internal resistance. dq, let's rewrite again. EI dt is equal to IR dq, everywhere will be equal to I dt plus IR into I dt. In the next step, I square R dt plus I square R dt. Now we can cancel dt, so we'll be left out with EI is equal to I square R plus I square small r. From here we can take I square common, R plus R, so EMF will be equal to I R plus R. With the help of this, you can find out the amount of current drawn from the circuit. I is equal to the total EMF divided by the total effective resistance. Here this R plus R is called the effective resistance of the cell, which includes the external resistance that you will be connecting to the circuit plus the internal resistance which is present inside the circuit. Since these two are in series, this will be R plus small r. This will be the amount of current drawn from the cell.